So the Mars Climate Rover was a 638 kilogram space probe launched by NASA on December 11, 1998, and they lost contact with it on September 23, 1999, when it passed behind Mars 49 seconds earlier than expected. Shortly after that, according to Wikipedia, it encountered Mars at a lower than anticipated altitude. That's a very polite way of saying that the ground wasn't where it thought it was and it burned up in orbit. So what happened? Well, it turns out that a piece of software provided by Lockheed Martin was producing results in Imperial, or our English Standard units, but the software produced by NASA that was receiving those results expected to get them in metric units. So the moral of this story is that units matter. You need to always be aware of what the numbers you're working with represent. And this isn't just a topic for engineers and scientists either. If you're traveling out of the country, for example, you'll have to convert your home country's money into the local currency. That's a conversion, right? You also may have to convert speeds, for example, from miles per hour to kilometers per hour, or vice versa. Okay, so how do we do these conversions? Well, it's all based on knowing two equal values, right? One for the unit that our measurement is in, and one for the measurement that we want it to be in. For example, I know that 1 foot equals 12 inches. I want you to think about this for a minute, all right? What I have here is an equation, and I can do all the things to it that you already know how to do to algebra equations. For example, I can divide both sides by 12 inches. Now, this is the magic part, right? Look at what happens on the right-hand side. These 12 inches, they both cancel. And I'm left with 1 foot divided by 12 inches equals 1. And that is really the magic part. The ratio of the two known lengths is equal to 1. And it's a basic math principle that multiplying by something that's equal to 1 doesn't change whatever you multiply it. So, for example, right, let's say I have a measurement like 18 inches. Right, and I want to convert this into feet. Well, I can multiply that by 1 foot divided by 12 inches. And that doesn't change its value because that ratio there, the 1 foot divided by 12 inches, is equal to 1. All right, but now look, I can cancel these inches just like you would a number or a variable. And all that leaves me with is 18 twelfths, or 1.5 feet. And that's the end of the conversion. 18 inches is equal to 1.5 feet. Right, so now let's take a step back, right, and think about what we just did. I started with the two known quantities, 1 foot and 12 inches. And I divided one by the other. Then I multiplied my known measurement, the 18 inches, by that ratio. All right, now a common question I get asked is, how do you know if we should multiply by 1 foot per 12 inches or 12 inches per 1 foot? Because those are both equal to 1. Right? Well, the answer is to think about where you want to end up. If you're starting with inches, for example, like I did here, then you want the inches to go away. Right? So to make that happen, the inches have to be here on the bottom of the conversion factor so that they cancel with the inches in the original measurement. Right? And on the other hand, if I wanted to convert, for example, 1.5 feet back into inches, I would put the feet value on the bottom and the inches value on the top. So hopefully you're catching on that the key to this whole process, right, is knowing these conversion factors, that is, these matched pairs of units. So I've got a few examples here for us to practice with. What I want to know is, how many miles are there in 3,000 feet? All right, well, I'm starting off with 3,000 feet, and I know I want to get rid of those feet. So whatever conversion factor I use, feet is going to have to go down here in the bottom. Then the feet are going to cancel, and all that's left will be the unit that's on top. That's the one I want. So I'm going to put miles up here. Now, I'm looking at my conversion factors over here. I'm seeing if I have one that has feet and miles. Well, this bottom one will do the trick, right? There's 1 mile, 5,280 feet. And if you get your calculator out and do 3,000 divided by 5,280, you get 0.568. And look at what the units do. The feet cancel, and all that's left is miles. Right? And there's my result. There's 0.568 miles in 3,000 feet. Okay, so how about this one? How many yards are there in a mile? Well, okay, I'm going to start with miles, right? 1 mile. And now I'm immediately going to run into a little bit of trouble. I don't have a conversion factor that will take me from miles into yards. Right? And that's okay. But this is going to happen. Look, here's what I'm going to do. I'm going to go from miles to feet, and then I'm going to go from feet into yards. Right? So I'm just going to have to use 2 steps. So first, let's see. There's 5,280 feet in 1 mile. That takes me to feet. Right now, I want to go into yards. There's 1 yard in 3 feet. Watch the units. The miles cancel. The feet cancel. All I'm left with for the units is yards. Right? You get your calculator out. 5,280 divided by 3. That's 1,760 feet. Right? And that's it. There's our answer. Okay. Did you know all the conversion factors I listed here? Right? The English or imperial system that's used here in the U.S. has dozens of these factors. 16 ounces in a pound, 2.4 acres in a hectare, 660 feet per furlong. Okay, I'm picking obscure units here, right? But that illustrates the point. Even if you stick to just the common units like feet, ounces, and cups, there are still an awful lot of these factors you would need to know. And there's no kind of pattern to them. You really just have to memorize them. Right, well, in 1670, a French gentleman named Gabriel Mounton in Lyon, France, proposed an alternative called the metric system, where converting between units was much simpler. Right, so that's what we're going to talk about in the next lecture in this series.